Hello everyone, this is Haripriya, PhD scholar from Tamil Nadu Agricultural University, and I am here to present on the topic elevated temperature and carbon dioxide influences the population dynamics of a specialist crucifer pest, Plurella xylostella. We know that climate change is the major threat the world is facing now. The Intergovernmental Panel on Climate the 1.5 degrees Celsius rise in the surface air temperature by 2030 and 2050. And also, the carbon dioxide concentration in the atmosphere is also rising every day. And the maximum of 414 ppm was recorded during the year 2019. And what happens to the insects when there was an increase in temperature and carbon dioxide? This is our question, unsolved question. To find out that we have experiments on elevated temperature and carbon dioxide on the population dynamics of a Plutella xylostella in cauliflower. So what we have done is that we have set three different treatments. One is at ambient and two elevated temperature and carbon dioxide conditions at SPAR chamber, which is Soil Plant Atmospheric Research Chamber located at Agroclimatic Center, Tamil Nadu Agricultural University, and where we have raised the cauliflower plants in pots, and the nucleus culture of Plutella xylostella were collected from different locations, and freshly laid 100 eggs were taken, and they were subjected to different treatments, and they were observed every day. The developmental time, mortality, survival, and the number of offsprings produced by the adult females were recorded every day. And the bionomics of the Plutella xylostella were analyzed by using 26ms chart. And what we could find is that the survival of the diamondback moth has reduced when subjected to elevated temperature and carbon dioxide condition. That is, at 33 degrees Celsius and 460 ppm, we could see a decline in the life expectancy. The Plutella xylostella survived up to 28 days at ambient condition of 31 degrees Celsius and 14 ppm, while it reduced to about 18 days at 35 degrees Celsius and 560 ppm of carbon dioxide. While when we see the fecundity, that is the number of offsprings produced by an adult female, we could see that the fecundity rate is maximum at elevated temperature of 33 degrees Celsius and 460 ppm. An individual female produced about 120 eggs in their lifetime at elevated temperature and carbon dioxide condition. And when we analyzed the life table parameters, we could see that the net reproductive rate reaches a maximum of 90 above when the temperature and carbon dioxide level is elevated. And there was a drop when it was more elevated to 35 degrees Celsius and 510 ppm of carbon dioxide. And when we see the intrinsic rate of increase, that is the rate of progeny production per female, we could see that the intrinsic rate was maximum at 35 degrees Celsius and 510 ppm of carbon dioxide. And when going to the population doubling time, when we could see that the doubling time decreases when there was an elevation in carbon dioxide and temperature. Now, what we could expect out of this, through this, we could see that even though the survival rate is reduced, we could see that they can produce more number of progenies at elevated temperature and elevated carbon dioxide condition, and the number of generations also will be increased under the elevated conditions. So what we could infer here is that the elevated temperature and elevated carbon dioxide conditions have a negative impact on the survival rate, while it positively influences the fertility. That is, the fecundity gets increased when exposed to elevated conditions, and which in turn could increase the population buildup in the farmers' field, and the farmers have to apply more number of pesticides, and which could increase their cost of cultivation also. And what we could do to combat these problems is that we should follow climate resilient agricultural practices, and we should understand the crop pest relationship in a better manner. And we could also go for screening of heat tolerant varieties, which would prove solutions for these problems. And we are also planning to use modeling softwares such as ILSIME and Climax and various other softwares, so that we can predict the population dynamics in the future days that are going to come. Thank you.